Got another paper 3 question for you to try. So this one covers stereoisomerism and reactions of organic functional groups. Hope you like the video, and if you haven't already subscribed, why don't you consider subscribing to the channel. But as always, the link to the questions in the description of the video if you want to try it first. So we'll start with the type of stereoisomerism shown by A. So you'll hopefully notice that this carbon here has got 4 different groups attached to it, so it's a chiral center. So compound A can show optical isomerism. So what we need to do next is draw the 3D structures of the optical isomers. So starting with an empty tetrahedral structure, just need to sort of decide where the groups are going to go, and there's no order to this. So I'm going to put the CH2OH on there. I'm going to put the CN on the dashed line. I'm going to put the COCH3 on the wedge, and that means the hydrogen would go on the solid line. All I need to do now is mirror that. Then the only other thing we need to say is that these optical isomers are non-superimposable mirror images of each other. So moving on to the reactions of the 3 functional groups, we've got a ketone, we've got a nitrile, and we've got an alcohol, specifically a primary alcohol. So all I'm going to do is run through the possible reactions you could have gone for. So you could have reacted the ketone with NaBH4, that's a reducing agent, so it's going to reduce the ketone functional group to a secondary alcohol. Alternatively, you could have reacted it with a mixture of KCN or NaCN in acid, so I've gone for sulfuric acid. You could even just right there react with HCN, and you can see that the ketone functional group has been turned into a hydroxynitrile group. Moving on to the reactions of the primary alcohol group, so we've got acidified potassium dichromate under distillation, and that primary alcohol is converted to an aldehyde. Alternatively, you could use acidified potassium dichromate but heat under reflux, and that would go to a carboxylic acid. Another reaction you could have gone for is the reaction with compound A and sodium halide and sulfuric acid. So I'm just representing the sodium halide as NaX. So what happens there is the alcohol OH is substituted for halide. Another reaction of the alcohol group, you could react it with a strong acid, so something like sulfuric or phosphoric acid, and heat it, and basically the alcohol group is turned into an alkene group. So you eliminate an H2O molecule from the alcohol. And the final reaction of the alcohol group is a reaction between a carboxylic acid, so I've gone for ethanoic acid, and a sulfuric acid catalyst with a bit of heat. And what happens there is the alcohol group becomes an ester. So finishing off with the reactions of the nitrile group, so you could react it with hydrogen and a nickel catalyst, and what that will do is it will reduce the nitrile group to an amine group. So the CN becomes CH2NH2. And the final reaction is a reaction of the nitrile group with an aqueous acid with some heat, and you can see that the nitrile group has been hydrolyzed and it's become a carboxylic acid group. So I'm pretty sure that they're all the reactions that you could have gone for, but remember you only had to go for one for each functional group. So hopefully I covered the reactions that you chose.